Thank you, Detlef. Sorry that I could not come to Potsdam, but I will give you an update on the efforts of our working group, and it's towards an updated reference level, Ellipsoid. The title of the working group is Consolidation of a Best Estimate GRS based on the adopted W0 of the IHRF. So the best estimate, but main goal is to bring consistency into the use of geodetic parameters, and so to have a more accurate reference model of the Earth. So the focus is on consistency and not on best estimate. So our goal is not to determine better defining parameters that are not documented yet. So we would really like to base on already existing parameters. The bases are the latest IERS conventions. So for GM and omega, the Earth rotation. Then we have the SLR time series for the J2. And of course, we have the IHG resolution of 2015 of the W0. So we chose these four parameters, so GM, J2, U0 or W0, and omega, and as defining parameters, and they are all have a physical meaning, and they are observable, including temporal variations. Another argument was given by George Banu at the EGU this year. So he set up a correlation matrix of possible defining parameters, and we really see that the parameters that we chose are practically uncorrelated, which is not the case as if we would choose A, the semi-major and semi-minor axis, as defining parameters. So they are not correlated, are independent, and so we can give reasonable values also for the standard deviations of the derived parameters. We have some basic principles, the tidal system. So we will calculate everything in zero-tide system, but we will give the conversion to other tidal systems and calculate them. We will not go for every minor detail, so we will neglect some second-order terms in order to keep everything as simple as possible. For the conversion between the tidal systems, the formulas are well known, and they are summarized by, for example, by Jaakko Mäkkänen or also by Ropesh Goyal. Then time system. Last year, I still said we will calculate everything based on terrestrial time. In the meantime, I changed that a little bit, and I think it's more appropriate to go to the barycentric or geocentric time in order to be more consistent with the SI second. But on the other hand, I don't think that it's a good idea to redefine terrestrial time, which we could do if we change the standard value of W0. But the problem is that the constant LG for the conversion between geocentric and terrestrial time is a defining parameters for the International Astronomical Union. And I don't really think that it is appropriate that we start to play around with this definition and try to change LG. So LG, as it is now, is based on another W0, but I don't really think that it is a big problem. But I would be interested to hear your opinion on this. Then time dependency. All quantities are time dependent. There are long-term and seasonal trends in every parameter. And but to keep things simple, the new GRS should be static, and we can try to calculate the parameters for a certain epoch, or we just can declare them as conventional parameters. Last year, I made the first choice of these defining parameters, and then we checked all the derivations of derived parameters. So we have verified all these calculations independently. So especially Ropesh Goyal and George Banu helped me in this. And so we could verify that with different software and different methods, we get the derived parameters, so especially the geometrical parameters such as AB, but also normal gravity at the equator and pole, or everywhere on the ellipsoid surface, agree within all the necessary decimals. There are some more presentations this year that were presented by working group members, so posted by George Banu at the EGU, then a presentation by Ilya Shchepkov at the GGHS just some weeks ago, and another posted by George Banu as well as the GGHS. Some more words about thermal changes. So we have this, I start with the angular velocity, omega. So we see it here, the time series for over some decades. And there is one special parameter that is defined as in the IERS, and that is the same as it was used already in GRS 80. There is not really a big difference if we would choose now a new value or do other mean, or we do it for the epoch 2010 or anything. That doesn't change too much. So I would say that for omega, we just keep the IERS 2010 value as fixed and use it and continue to use it. What's this? Okay. Another temporal variation of W0. I took this from Laura's paper. So that's the best moment for such things. This is the change in W0 over some years. And the adopted value for the W0 is a rounded value for the year 2010. And I think we should not change it as well, and try to and will continue to use the W0 value as it was adopted in 2015. Temporal variations of J2. This comes basically from SLR time series. So this parameter is really depending on the tide system. But if we see the time series and the IERS 2010 value, as I highlighted here, I don't see really a necessity to use another one than the one from the IERS 2010 conventions. So I would as well keep this as it is. For GM, there are not really time series available, but only different solutions by various authors. So we have the value of the IRS conventions is given in barycentric time, or converted to terrestrial time, it's a small change in the value. And all the other current or recent determinations differ from these published values only within the 1 sigma, or much less usually. So I don't really think that it's appropriate as well to make any changes in this value. So we have a first proposal for the use of the defining parameters. They are basically the same as we presented them already last year. Just for the GM, I changed to the barycentric time, and I corrected the typo that I had in the J2 value. So if you see my old presentations from last year. So in summary and conclusions, we have a first proposal for the defining parameters of a new conventional GRS. It's heavily based on the ERS conventions 2010. And we don't have an intention to really change these values to really have a best estimate value for these parameters. We have calculated them in zero-tide system and barycentric time. The calculation of all derived parameters is verified and consolidated. So if we once agree on the defining parameters, we immediately will have all the other derived parameters. As well, conversion of tidal systems and time scales, they are well known and well documented. And we have to calculate or give some kind of transformation for ellipsoidal coordinates, ellipsoidal heights, normal gravity between the new GRS and the GRS 80. That's ready as well, now, more or less. The next steps are consolidate the defining parameters, and of course, we should prepare a publication of all these calculations and derivations. That's all I wanted to say. Thank you very much.
Thank you, Urs, for this presentation. Are there questions or comments? Yeah, Hartmut?
Yeah, I have a quick question. How much would normal gravity change due to the new definition? Is there already an estimate? Is it in the milligauss range or less?
It's in the order of 1/10 of a milligauss. It's latitude dependent, and I think it's between 70 and 110 microgauss. But has to be verified.
Urs, I have a question concerning the next steps. So what is your suggestion? If we have a consolidated set of parameters, should we then go for an IAG resolution for a new geodetic reference system, or what is your opinion on that?
I think we should aim to that, but in order to be able to have something ready in 2027, I think next year we should have published what we did and what we propose, so that people will have enough time to discuss it, and we can make changes, important changes, well before the IUGG conference.
Okay, yeah, I agree with that. Thank you. Are there other?
Just to comment that GRS 80 was the resolution. The resolution for the GRS 80 was released by the IUGG, not only by the IAG. I think it will be interesting to have the support of the IUGG if we want to.